Hello dear students, welcome again to Rouse's class. And in the previous class we discussed about Graham's law of diffusion, and today we are going to see some questions based on Graham's law of diffusion. These are the questions based on Graham's law of diffusion, right? So yes, you will understand these questions then only when you watch the previous video. I hope you watched the previous video. Now let us see these questions. Yes, this question is asked in 2014 IIT 2014 IIT question. You see what is the question asked. X and Y are two volatile liquids with a molecular weight it is a 10 gram per mole and 40 gram per mole. This is the molecular weight of X and Y respectively. Means this is the molecular weight of X and this is the molecular weight of Y. This is the X and this is Y, right? Now two cotton plugs soaked, one soaked in X and other soaked in Y, are simultaneously placed at the end of a tube length 24. This is the length of the tube, which is 24 centimeter as shown in the figure. It's a figure. So the tube is filled with inert gas at pressure 1 atm. Pressure is 1 atm and temperature is 300 Kelvin. The vapors of X and Y react to form a product which is first observed at distance D. This is the distance D. D centimeter from a plug soaked in X. Take X and Y to have equal molecular diameter and assume ideal behavior of inert gas and the two vapors. So what they are telling is, here cotton wool soaked in X and here cotton wool soaked in Y, it is kept the total distance 24 centimeter. Here for the first time the reaction has done, this distance is D, and what is that D we have to find. Yes, see the questions. This is the question number 1. The experimental value of D means not density, it is a distance. The experimental distance is found to be smaller than smaller than the estimate obtained using Graham's law. It means this is the theoretical distance. This is theoretical distance, right? Now the experimental distance is somewhere here. The experimental distance is less. So experimental distance is less than theoretical distance. The question is why? So what might be the reason that we have to think? Larger mean free path for X as compared to Y. Mean free path means distance. So the distance traveled. The larger mean free path of X as compared to Y. Larger mean free path for Y as compared to X. Increased in collision frequency of Y with inert gas as compared to X. Increased in collision frequency of X with inert gas as compared to Y with the inert gas. So these are the possible options. So why the distance has decreased? Distance has decreased because the experimental collisions, the collision between the molecules must be very high. So here the correct option is increased in collision frequency. Here collisions, here inert gas is already there. Here let us say any inert gas is present, and that inert gas will, this X gas will strike as well as this Y gas will also strike, and that's why this collision will decreasing the speed of travel. So here the traveling distance is decreased. Here the smaller distance, here x is moving slowly and y is moving faster, which means x is facing more collisions with inert gas. So which means increased in the collision frequency of x with inert gas as compared to that y. That's the answer. So therefore answer is D. Understood it? Understood? I repeat once again. So actually this was supposed to be this meeting point of x and y, but the experimental distance is coming less than theoretical distance, means experimentally they are meeting at this point, right? So if you listen carefully, then you will understand. So it means x is moving lesser distance than y. So why is it so? Because x is facing more collisions with noble gas. That is what is said, increased in the collision frequency of x with inert gas as compared to that y with inert gas. So x is facing more collisions, that's why x is traveling less distance, y is traveling more distance. Had the question been like this, the experimental distance is more. If the question is like this, then it means y is traveling less, x is traveling more. In that case, the answer should have been C. But now the answer is D. So I hope you understood it. Still, if you don't understand, rewind the video and see. Next question. The value of D shown in the figure as estimated from Graham's law. So you have to find the distance. This kind of question we discussed in the previous class also, but still if you don't understand, then just go through the video and I'll explain here also. See, question number 1, it is the second part. This is the IIT question, second part. This is the a long tube, and long tube total distance is 24 centimeter. And here they are meeting at point C. So this is, let us say, A, it is a B, it is a C. So this distance is D. So then what will be this distance? It is a 24 minus D, correct? Now, so here we kept here X substance and here we kept Y substance. Now, as per Graham's law, of diffusion, what can we say? The rate of diffusion of X over the rate of diffusion of Y is equal to molar mass of Y over molar mass of X. Is it right? Which implies the rate of distance of X means X traveled distance, that is AC over it is a BC, which is equal to molar mass of Y is given in the question, that is a 40, molar mass of X is 10, that is a 40 over 10. Yes, AC means it is a distance D upon BC means 24 minus D, which is equal to root 4. Root 4 is equal to 2. So distance D is equal to, what can you write? 24 minus D into 2. So D is equal to 48 minus 2D. So this one will come this side. So you can say 3D is equal to 48. So D is equal to 48 by 3, which means 16 centimeter. 16 centimeter. You check the option. Yes, it is there. 16 centimeter. This is the answer. Clear? So this is about a second question based on Graham's law of diffusion. Yes, you can give feedback in the comment box if you, whether you are liking my videos or you have a still problem. So, or whether I am giving with more speed or little less speed, whatever it is, you can give in the comment box. Thank you guys. Yes, now coming to the second point, second question. Let us see. At certain temperature, the time required for complete diffusion of 200 ml of H2 gas is 30 minutes. The time required for the complete diffusion of 50 ml of O2 gas. So time required is question mark. So yes, it is about time. So time questions, we know the formula. So question number 2. Let us write the given data first. Given data is time required for 200 ml of H2 gas is, how much time it is taking? 30 minutes. Is it clear? 30 minutes. Now the time required in the second case, T2, is question mark for complete diffusion of volume. Volume V2 is equal to 50 ml for O2 gas. For O2 gas, what is the volume? That we have to find. As per Grahams law of diffusion, what is the formula? R1 by R2 is equal to V1 by V2 into T2 by T1. Yes, that is the formula, which is equal to under root M2 over M1. So here let us say this is all about first case. This is all about first case, and the second one, it is all about second case. Now which means V1, what is the volume of first gas? It's a 200 over V2, it is a 50 into T2. T2 we have to find upon T1, which is 30, is equal to under root molar mass of second gas. Second gas means O2, that is a 32, divided by M1, that is a hydrogen, its molar mass is 2. So which is equal to under root 16, which is equal to 4. Now simplify this one. 51s are 54s are, this 4 and this 4 get cancelled. So T2 is equal to 30 seconds. So T2 is 30 seconds. You just see, yes, T2 30 seconds is there. So this is going to be our answer. Clear to all of you? So very simple. This is the formula. R1 by R2 is equal to V1 by V2 into T2 by T1, which is equal to under root M2 by M1. This is the Grahams law formula. Based on the formula, we have solved it. Right? Yes. Now moving on to the next question. Yes, you see the third question. This is the third one. 0.5 mole of each hydrogen, sulfur dioxide and methane are kept in a container. A hole was made in the container. After 3 hours, the order of partial pressure in the container will be. So what they are telling is, you take a container here, container. So equal amount 0.5 mole of hydrogen is there, sulfur dioxide is there, and methane is there. So now after some time, this is a closed one, closed container, you made a small hole here, small hole. So gases will come out. So pressure in the container will be. So how can we solve it? Just think about it. We have to find the rate of diffusion. Rate of diffusion is inversely proportional to molar mass, correct? Here hydrogen molar mass is 2, sulfur dioxide molar mass is, sulfur mass, what is the sulfur mass? 32 and 32, it is going to be 64, and CH4 molar mass, CH4 molar mass is 16. So here, due to hydrogen very low molar mass, it comes out very fast. Hydrogen will come out very fast. So the rate of diffusion order will be, so hydrogen will come out very fast, then methane will come out because its mass is 16, then sulfur dioxide. Now inside the container, hydrogen will be less. That's why the partial pressure of hydrogen will be less in the container, then partial pressure of methane, then partial pressure of sulfur dioxide. This is the answer. This is inside the container. Understood this point here? Yes, I repeat once again. Here, rate of diffusion. Here hydrogen molar mass is very less, so it comes out very fastly. Diffusion is very more. Hydrogen will come out, then methane will come out, then sulfur dioxide. So inside the container, very small amount of hydrogen is left. That's why the pressure due to hydrogen will also be less. Then pressure due to methane, then sulfur dioxide. So you check the options. Which option will come? Sulfur dioxide should be first, then methane, then hydrogen. So the answer is this one, option A. Clear it? Okay. Now next question, fourth one, which is asked in NEET 2016. NEET 2016. Equal moles of hydrogen and oxygen gases are placed in a container. It means you take a container, equal moles of hydrogen and oxygen are kept. Let us say x mole. X mole. What fraction of oxygen escapes in the time required for 1/2 of hydrogen has escaped, or hydrogen to escape? So I'll solve the answer here only. Let the number of moles of hydrogen is x mole, which is equal to number of moles of oxygen. That is what they said. Equal moles of hydrogen and oxygen are placed in a container. Now you made a small hole. The question they are asking, what is the time taken? Or I can say we have to find what fraction of oxygen escape out when x by 2 mole of hydrogen goes out. Right, understood this one. So what fraction of oxygen escapes in the time required for 1/2 of hydrogen escape? Here hydrogen is x mole, so x by 2 mole time. In that time, what fraction of hydrogen will escape? That is a question. So we have to understand the given data. Without understanding given data, you cannot go for planning and you cannot go for solving the question. Now what I will do is I will go for the same method. The rate of diffusion of first gas upon second gas is equal to V1 by V2 into T2 by T1, which is equal to under root M2 over M1. Right. So what is the first gas here? First gas is hydrogen gas. So let us say this is M1, which is equal to 2. Second gas is oxygen gas, that is M2, which is equal to oxygen molar mass, which is 32. V1, see, volume is directly proportional to number of moles. So instead of V1, I can write N1 also. So instead of V1, I can write N1. So this formula I can write as N1 over N2 into T2 over T1 is equal to under root M2 over M1. Now solve this question. N1, how much N1? N1 means number of moles of oxygen, that is x by 2 mole. X by 2 mole of oxygen upon N2 is a question mark. Time taken, the time required is same for both. So time is same, so which get cancelled, which is equal to under root M2. Molar mass of second gas is 32 upon first gas, it is 2. Understood? So because what fraction of oxygen escapes in that same time required, same word is not given, but we have to understand in the same time required for 1/2 of hydrogen escapes. So here the word same, had it been given, it would have been very clear, but they did not give. So you have to understand that same time required for 1/2 of hydrogen to escape. So T1, T2 get cancelled. So now it is going to be under root 16, which is equal to 4. So x by 2 is equal to 4 into n2. So which implies n2 is equal to x by 8. So x by 8 means 1 by 8 fraction will get escaped when half of the fraction of hydrogen gas get escaped. So answer is yes, this is 1 by 8. This is the answer. So it is a very simple question. In the container, so if the half amount of hydrogen is gone, then how much amount of oxygen would have been gone? Understood? If the half of the hydrogen is gone, how much amount of oxygen must have gone? That we have to find. So I used Grahams law of diffusion formula. R1 by R2 is equal to V1 by V2 into T2 by T1 is equal to under root M2 by M1. But here volume is replaced with the number of moles because volume and number of moles are directly proportional. Clear? Now the next question. Yes, this is asked in Kerala PMT question. So you see 4:1 mixture of hydrogen, helium and methane. 4:1 mixture means 4 moles is to 1 mole. You can say 4:1 moles of helium and methane. Helium and methane is contained in a vessel at 10 bar pressure. 10 bar pressure. Due to a hole in the vessel, the gas leaks out. The composition of the mixture effusing out initially means how much amount of hydrogen and how much amount of helium going out, which means ultimately we have to find the rate of helium diffusing to rate of methane, so with which ratio it is going out. That is what we have to find. Understood this question? So question is very tough. You have to think. This is one of my favorite question because it is not a direct question, it is an indirect question. Let us see the given data. The number of moles of helium is to number of moles of methane, that is 4:1, and the total pressure is given 10 bar. P total is equal to 10 bar. Then how can we solve this question? So is there any plan in your mind how to solve? There is a formula, that is rate of helium upon rate of methane is equal to pressure of helium upon pressure of methane. Pressure of methane into under root M2 or any mass of methane over mass of helium. This is the formula. If you can go through the previous video, you will come to know that where we have written the formula like this: R1 by R2 is equal to P1 by P2 into under root M2 over M1. This was the formula, and that formula I have just modified. This is the formula needed to solve this question. So now here everything is there, but we don't have pressure of helium and pressure of methane. So once if you have that one, that can be done. So pressure of helium is equal to, as per Dalton's law, P total into mole fraction of helium. So pressure of helium is equal to P total, how much it is given? 10 bar into mole fraction of helium means number of moles of helium over number of moles of helium plus number of moles of methane, which is equal to 10 into number of moles of helium is a 4 divided by 4 plus 1, that is a 5. So it's going to be 5 to the, it's going to be 8 pressure of helium. Similarly, pressure of methane we have to find, which is equal to P total, it is a Dalton's law formula, into mole fraction of methane. So which is equal to P total is a 10 into number of moles of methane, which is a 1, over, it is a number of moles of methane 1 over total number of moles, which is going to be 1 plus 4, that is a 5. So 10 into 1 by 5, that is equal to 2. So now we got everything. That's, let us put this in this formula. So we will put in this formula. So what you will get, rate of helium upon rate of methane is equal to pressure of helium, how much it is, 8 over pressure of methane, it is a 2 into under root molar mass of methane, it is a 16 over molar mass of helium, that is a 4. So it is a 4, which is a 2 cancelled, so which is a 8. So the ratio is 8 by 1, so which means 8 is to 1. So you can check here, 8 is to 1. Yes, this is the answer. Clear? This is a tough question, so just go through the video once again, and definitely you will understand it. So I hope I'm completely transferring my knowledge. I hope you are understanding my videos, and if you like it, just share with your friends and let them also learn the things. And if you want to say anything, you can share in the comment box. Right? Thank you guys. Thank you, and take care of yourself.